Welcome to a new episode of the podcast. Vox Agent is made by AI for business executives that work with AI. Today, we're diving into a challenge that's, it's becoming undeniably central for any business leader leveraging AI: how to truly unlock the full potential of agentic AI. We're talking about those autonomous systems, the ones that can handle complex, multi-step tasks. Our mission today is really to explore a fundamental hurdle many organizations face: this issue of fragmented data and how overcoming it is absolutely critical to harnessing AI at scale. Consider this your shortcut, really, to getting well-informed on a topic that's rapidly defining the competitive landscape. So let's set the scene a bit. The buzz around agentic AI, it's everywhere. These incredibly intelligent software agents that can orchestrate entire processes, right, from customer service all the way to supply chain management. The race to implement them is definitely on, but we're seeing so many organizations kind of hitting a wall. And it's often not about the AI models themselves, surprisingly. Why? Because an AI agent, no matter how brilliant its algorithms are, is ultimately only as powerful as the data it can actually access.
Exactly. That's spot on. And the core problem we consistently observe is fragmented data. Just picture your organization's data, scattered across countless isolated pockets, different platforms, maybe a myriad of incompatible formats. This fragmentation severely impedes an AI's ability to even see the full picture, let alone function effectively. What's truly alarming, and maybe a hidden cost many overlook, is just the sheer inefficiency this creates. CIOs are reporting spending roughly 20% of their entire IT budgets just on integrating and managing this siloed data. Now compare that to maybe 5% allocated to AI itself. That ratio, it tells you exactly where the biggest bottleneck, the silent budget killer, truly lies.
Okay, right. Let's unpack this a bit more then. When we talk about data silos and fragmentation, what does that actually look like on the ground? And how does this sort of jumble of disconnected information specifically inhibit an AI from doing what it's supposed to do, which is, act intelligently?
Well, think of data silos as these isolated islands of information. Imagine different departments using completely separate software systems. Maybe your sales team's on one CRM, finance on a different ERP, customer support on another platform altogether, each with its own database. That creates a silo, right? A walled garden of data. Now, data fragmentation is a bit broader. It's where enterprise data is simply scattered in many places and formats without any unifying structure. So, for instance, comprehensive customer data might exist across, say, 5 different databases, one for purchase history, another for website interactions, a third for service calls. This leads to an incomplete or sometimes even conflicting truth about your customer. So your AI models, no matter how sophisticated they are, will inherently overlook crucial correlations because they just can't see the whole picture. And for you, the listener, this means AI models trained on incomplete or inconsistent data can lead to incorrect, biased, or even risky autonomous decisions. It truly underscores what we're starting to call a data estate race that's happening right alongside the race to build better AI models.
That makes perfect sense, yeah. It sounds like fragmentation isn't just an inconvenience, it's a fundamental barrier. But for those cutting-edge agentic AIs, the ones we're hoping will truly transform operations, how crippling is this fragmentation really? Because they're designed to do more than just simple analysis, aren't they? They're supposed to actually take action.
Precisely. That's the key difference. Agentic AI needs wide-ranging, high-quality data, and critically, it needs it in real time, not just historical snapshots. Imagine an AI customer service agent. Not one that just answers a question, but one that proactively manages a customer issue end to end. From diagnosing a problem by pulling up purchase history and previous interactions, checking current inventory, perhaps scheduling a repair technician, even sending a follow-up. For this AI to truly act, it needs to pull information simultaneously from CRM records, transaction logs, knowledge bases, maybe social media feeds, supply chain data, all in milliseconds. If that data is fragmented, locked away in different systems or formats, the agent simply can't do its job effectively. It stalls. As one technology executive put it very eloquently, and it's a truth we keep coming back to, the smartest agents are useless without the right data behind them. Great AI relies on great data. Without that unified, comprehensive data foundation, these powerful AI agents are essentially, blind and inert.
Okay, so if fragmented data is this pervasive, fundamental problem, what's a counter strategy? This sounds like where the concept of a unified data estate really comes into play. What exactly is it?
It is indeed the core strategy. A unified data estate is essentially an integrated architecture. It brings together all of an organization's structured data like your financial transactions, unstructured data like emails and voice recordings, operational data from real-time systems, and analytical data used for insights. All of it. It puts all of this under common management and governance. The ultimate goal here is to create a single, cohesive, and importantly, trusted source of truth for all enterprise data, making it readily accessible,
consistent, and secure for any application, but especially for AI.
Right. Here's where it gets really interesting for me. How are organizations actually building these? What are the common architectural approaches that consolidate all this diverse data and turn it into that unified estate you mentioned? Because it sounds like it's probably not a one-size-fits-all solution, is it?
No, you're absolutely right. It isn't. There are several key approaches, and they're often used in combination or maybe evolve from one to another. Historically, we had the Enterprise Data Warehouse, the EDW. Think of it as a highly organized, sort of pristine library for structured analytical data, great for consistent reporting. Systems like Snowflake or Amazon Redshift are classic examples here. They give you clean, curated data, which is excellent for AI needing historical structured analysis. But they weren't really designed for the explosion of raw, diverse data we see today. So this led to the rise of the data lake. Now, imagine a vast, unfiltered reservoir for all your data raw, semi-structured, unstructured, you name it. It's flexible and cost-efficient for storing massive volumes, which is perfect for training complex machine learning models that thrive on raw data. Think Amazon S3, for example. But the downside, without proper governance, a data lake can quickly become a data swamp, difficult to navigate or actually extract value from. Which brings us to the natural evolution. The data lake house. This is really the convergence, the best of both worlds. Imagine that raw data reservoir, but now with built-in filtration, organization systems, and strict governance rules. It essentially combines the low-cost, scalable storage of a data lake with the management and performance features of a data warehouse. Technologies like Delta Lake or Apache Iceberg are key here. They help eliminate data duplication and silos, allowing one system to handle both traditional analytics and advanced AI workloads from the same data repository. For your business, this translates to simpler architecture and, crucially, faster time to value. Now, beyond these storage-centric models, we also have architectural concepts like the data fabric. This is less about where the data lives and more about how it's connected. It's like an overarching, intelligent connective tissue. It stitches data together from diverse, distributed sources, often without needing physical centralization. Gartner predicts over 60% of enterprises will be using data fabrics by 2025. Why? Because it significantly speeds up data discovery and integration across your existing complex landscape. Think of it as a smart overlay. And finally, there's the data mesh. This is a bit different. It's more of a decentralized, domain-driven organizational approach. Here, business domains like marketing or sales own and manage their data as products, just like they manage a customer-facing product. It complements the data fabric by distributing accountability. It ensures data quality and documentation are managed by those who understand the data best. This, in turn, tends to accelerate data product delivery and reduce central IT bottlenecks. So ultimately, these components often function together in a layered architecture. You have ingestion, intelligent storage, metadata management, unified governance and security, and then the application layer. But what's truly crucial across all these approaches is the role of unified governance, data quality, and ironclad security. These are what turn a massive raw data into a truly trusted asset for AI. Because for your agentic AI to succeed, that unified estate absolutely must provide three core capabilities. The breadth of data it can access, the timeliness of that data, meaning it's fresh, often real time, and absolute trust in its quality and accuracy.
Okay, wow. This all sounds incredibly ambitious, maybe even complex to implement properly. So, what's the compelling payoff here? For your organization, what's the tangible value proposition for going through all this unification effort? What are the real bottom line benefits?
Oh, the benefits are not just compelling. They really directly impact your organization's ability to compete and innovate. It's fundamental. First, you get dramatically improved AI performance and accuracy. It's simple. AI models are only as good as their training data. With comprehensive, high-quality unified data, they just perform better and made fewer errors. For example, Adobe Population Health saw their care management AI dramatically improve by unifying patient records. It ensured the AI had the right data for more thoughtful, more useful responses, helping them flag at-risk patients much more effectively. Second, it leads to faster time to insight and decision-making. Data professionals typically spend, 80% of their time just finding and preparing data. It's crazy. A Forrester study found that with a unified analytics platform, data engineers boosted productivity by 25%. They spent 90% less time on data search and integration. That saved something like $1.8 million in engineering time. And business analysts, their output improved by 20%. It means answers and actionable insights in minutes or hours, not weeks or months. Third, significant operational efficiency and cost savings. It's just inherently expensive maintaining multiple siloed systems. Think about duplicated storage, redundant data pipelines, the overhead of managing all those legacy systems. A top U.S. bank, for instance, forecasted nearly $40 million in savings just by retiring hundreds of legacy applications and archives after centralizing their data. And Microsoft Fabric users, they saw an average of $779,000 in infrastructure cost savings over 3 years. This isn't just IT savings, it's about major operational streamlining across the entire business. And finally, and this is where it gets really exciting, I think, new revenue streams and business opportunities. Unified data isn't just about internal efficiency, it unlocks genuinely innovative AI-driven products and services. Banks, for example, are leveraging unified data and AI for highly personalized financial services, or maybe embedding finance directly into other platforms. That's huge. Manufacturers are developing AI-based predictive maintenance offerings for their clients by combining sensor data from machinery with historical maintenance logs. They're turning a cost center into a new service line.
So, okay, what does all of this mean for you, the business leader listening? It seems pretty clear this isn't just about managing IT infrastructure or reducing technical debt anymore. Not at all. This is about establishing a direct, powerful competitive advantage. It's about enabling entirely new business models, delivering cutting-edge services, and significantly improving your organization's bottom line by truly unleashing AI's potential. This is great theory, but let's make it even more concrete. Can you give us some real-world examples? How are unified data estates truly powering agentic AI in action across different industries right now?
Absolutely. Yeah, the impact is already being felt across the board. It's not just hypothetical. In healthcare, companies like Adobe Population Health, who I mentioned earlier, are building personalized care coordinator agents. By unifying clinical records, lab results, medication history, even data from wearables, these agents can flag at-risk patients in real time. This prompts early intervention and, crucially, significantly reduces hospital readmissions. It's about giving the AI that complete, holistic picture of a patient's health for truly thoughtful care. Switching gears to financial services, we see sophisticated risk and compliance AI agents. Capital One, for instance, scans unified transaction and account data along with external market feeds to spot fraud anomalies. This enables real-time intervention to prevent losses. Other banks are using AI to interpret complex regulatory policies and adjust lending decisions or pricing automatically. They're making smarter, faster, and more consistent decisions across their entire customer base. Then in manufacturing, it's really all about predictive maintenance and self-optimizing production lines. Manufacturers like Tikkurila centralize their IoT data from factory sensors, merging it with maintenance logs. This allowed them to predict equipment failures with incredible accuracy, so they can schedule maintenance at optimal times, avoiding costly unplanned downtime. 3M did something similar and significantly cut their unplanned downtime. The AI can essentially see the whole production line and act preemptively. And even in professional services and IT operations, we're seeing transformative shifts. Certinia uses unified project and customer data to optimize staffing, proactively monitor project health, even predict project risks. This frees up human experts for higher-level client work. Similarly, AI ops platforms use unified log and telemetry data from IT systems for self-healing infrastructure. Agents automatically detect and resolve issues, dramatically reducing outages. The common thread you see across all these examples is clear. The more unified and trustworthy the data, the more powerful and wide-reaching the AI use case becomes. Companies are truly turning previously unused or siloed data into intelligent, autonomous actions that drive real business value. It's quite remarkable.
Okay, this all sounds incredibly transformative, almost like a must-do for any serious organization today. But for the business leader listening, what are the practical challenges in actually achieving this level of data unification? It certainly can't be all smooth sailing, can it?
Oh, absolutely not. You're right to ask that. There are very real and substantial hurdles. Let's be clear about that. On the technical side, integration complexity and data migration are huge. I mean, many organizations are wrestling with decades-old legacy systems. Moving or connecting all that data to a new, unified platform is incredibly intricate work. And ensuring data quality and consistency across all those disparate sources, that's another significant battle. Without diligent governance, a unified estate can quickly turn into an even larger data swamp if you're not careful. And then there's just managing performance and scalability for potentially petabytes of data, especially crucial for real-time AI applications. Then you have the implementation hurdles. Data governance, for example, becomes both more important and frankly more complex when you centralize data. Reconciling different departmental policies, setting up fine-grained access controls, getting organizational buy-in, that can be a massive challenge. You often hit departmental resistance over concerns about data ownership. There are also amplified security concerns. A unified data estate is, let's face it, a tempting honeypot for attackers.
It demands rigorous, even AI-specific security measures. And let's not forget the organizational and skill gaps. There's a well-known talent shortage in data engineering and AI. Plus, a significant mindset shift is often required to move from data hoarding to data sharing and collaboration. That's a cultural change. And of course, regulatory and ethical concerns are absolutely paramount. Privacy and compliance with regulations like GDPR or HIPAA become even more critical when sensitive data is concentrated. It requires careful management of data access and usage. The challenge of bias and fairness in AI models trained on comprehensive, unified data also needs to be actively addressed. You don't want to scale bias. And for autonomous agents, the ethical use and accountability for their decisions raise really important questions, often demanding a human-in-the-loop approach for critical oversight.
Right. Despite these very real challenges you've outlined, which are considerable, no doubt, what does the future hold here? For unified data and agentic AI, it still feels like an unstoppable necessary force for innovation.
It certainly feels that way, yes. And we're seeing exciting emerging trends that promise to make this journey perhaps more manageable and definitely more powerful down the line. One significant area is AI-driven data management. We really expect AI to increasingly manage data pipelines, quality checks, and even integration tasks autonomously. Imagine AI agents acting as data stewards, automatically detecting and fixing issues, or auto-generating metadata. This could profoundly democratize data engineering and really accelerate data readiness. Another big trend is real-time and event-driven unification. The old batch ETL process where data is processed in large chunks periodically. That's rapidly giving way to streaming data integration becoming the norm. For up-to-the-minute AI decisions, continuous data feeds will become standard. Think of things like AWS's Zero ETL integrations, which seamlessly replicate operational data for analytics and AI without complex processing steps. This makes real-time AI much more feasible, and we'll definitely see embedded AI directly in databases and data platforms. AI algorithms are becoming first-class citizens right inside data platforms.
Snowflake Intelligence, for example, is enabling business users to create data agents that can analyze and act on data via natural language. That's a big step. Google's BigQuery AI engine allows SQL users to create machine learning models directly in the database. It's blurring the lines between data processing and AI inference. So this all raises an important question, I think, for you, the business executive listening. What is the single most important message to take away from all of this? My conclusion really is that the unsexy work, the data integration, the cleaning, the governance, educating your teams on data best practices, this is the absolute bridge to AI's promise. Investment in your data infrastructure isn't just a cost center, it's the foundational work for truly scalable AI. It allows businesses to capitalize quickly on new AI innovations and frankly outcompete those still mired in data fragmentation. It's the critical step to move beyond pilot projects to enterprise-wide AI that actually delivers transformative value.
What a profound thought to end on. Really makes you think. For you, our listener, perhaps the ultimate race in the age of AI isn't just for the most groundbreaking AI models, but actually for building the robust, unified data infrastructure that fuels them. Those who master this foundational element, well, they will likely define the competitive landscape for decades to come. Thank you for joining the podcast, and see you soon.